Geological events shape fundamentally evolutionary history. And the evolution of life through time is predicated and depends upon having the ability to evolve and adapt to environmental conditions, but then instantaneously and unexpectedly having those environmental conditions changed, and changed drastically to the point where major swaths of what had evolved previously all go extinct. One of the best examples of this is what we call the KT impact. The K stands for Kreide, which is the German word for Cretaceous, and the Tertiary is the time period that follows that impact. So the KT impact was one of these geological meteor impact events that fundamentally determined the course of history and the organisms that eventually evolved, which were the mammals. So we want to think about what are the attributes and the processes that surround coming to the point of allowing a meteor to hit the Earth. When it impacts, what will it do to the planet? So let's just consider a little bit about a day in the life of the Cretaceous. We'd evolved to the point where the gigantic Saurischian theropod carnivores, T.Rex, Allosaur, the other big flashy meat eaters, they were the ones who were ruling the planet at that time. And let's just say it was a nice warm afternoon. There was a group of them that were hanging out on the Yucatan Peninsula in Mexico, which happens to be where the meteor impact hit, the KT impact. And let's just think about what happened at that moment. So there was a body of, we don't know if it was an asteroid or a comet. Some people think it was one, some people think it was the other. But another word that we use to describe it, a meteor, when we don't know exactly what it was, is we say that it was a bolide. There was a bolide hurtling through space at an average velocity of about 36,000 kilometers per hour, which is the average speed for most bodies that are traveling through space. So that bolide came hurtling towards Earth, and it was approximately 10 to 14 kilometers in diameter. And it hit the planet at those kind of incredible velocities. And one of the things that happened is as soon as it hit planet Earth, within 30 seconds, it created a hole in the planet at the Yucatan Peninsula that was about 5 kilometers in depth and upwards of 250 to 300 kilometers in diameter. So a hole that size was formed within 30 seconds. Now, on top of it hitting the Yucatan Peninsula, it hit partially on land and partially in the ocean. So at that time period, then not only did we form a hole that was gigantic on that kind of scale, but then we also displaced or shoved the seawater that was in the early Caribbean at that time. We shoved that away from the impact site. And when I say shove, I mean really shove this. It created the world's greatest tsunami. And that tsunami, a standing body of water that's rushing across the surface of the Earth, it might have approached sonic velocities. It, in some places, would have been upwards of 1/2 kilometer to 3/4 of a kilometer in height. Now, what are some of the lines of evidence that we have to reconstruct this? Because this sounds like quite a fanciful tale, but actually there are many lines of information that we want to consider here. And one of them is how much energy would have been released at that time. And so we have to remember that the energy that's released from a bolide hitting the Earth, it's not nuclear energy, it's kinetic energy. It's the energy of the body in motion stopping suddenly and having that energy transferred to the other body that it hits. But roughly speaking, if you were to take the entire Earth's nuclear arsenal at this time and then multiply that by about 100 million, that's how much energy was released at that moment. So we're talking about an incredibly powerful event. And what are the things that happened that were a part of this? So let's just go through the piece of evidence. First of all, we were able to age date these rock deposits that were associated with the impact hitting. What happens is that the crater is excavated into the Earth's surface, and all that material has to go somewhere. Some of it is blown out into space. Some of it is vaporized, actually goes beyond vaporization and goes to splitting the rock material and seawater material and the plants and animals and everything into their individual ions, and we call that a plasma. So instantaneously, we had all this material move away from the impact crater site. And some of it left the Earth's orbit, some of it was trapped in orbit, and some of it came back and fell as meteor showers. So the age of the rocks were able to be determined by the age of the rocks that the crater excavated, and then the age of the rocks that were ejected from the deposit, and also the age of the rocks and the sediments that were laid down in the impact crater after the event happened. Now, another thing, and this is kind of breathtaking, as you take a look at this image, it kind of chokes you up, right? Because you see here is one of our favorite carnivorous saurischians, Tyrannosaurus rex, and we're actually in the moment with T-Rex of the last thing that T-Rex would have seen before being completely vaporized and turned into nothingness by the force of the impact. So in the upper left of this diagram, we see that the impact bolide is coming towards Earth. It slams into the planet. One of the first things that happens before it hits and starts to excavate the crater is that the entirety of the column of the atmosphere gets compressed into a very small amount of space. And that compression into a small space, conservation of mass, that material of the atmosphere has to go somewhere, so it gets shot out laterally, and we call that jetting. So on the bottom part of this diagram, you can see there's a white disk that's radiating away from the impact site. So that compressed air was supersonic, and it was the temperature of the surface of the sun in many places, and that goes shooting across the planet. It radiates away from the central impact point. That's a bad thing, right? And T-Rex is going to be in the wave of this supersonically jetted wave of heated atmosphere that will obliterate this poor organism. But the next thing you see coming out of the crater is this shower of rock material. So that rock material, some of it goes into space, and if you see in the upper right, there's all kinds of shooting stars. And those shooting stars are some of the rock material from Earth that has been launched into space and then falls back into the planet. But other material doesn't get that high, and it falls back to Earth in this kind of cascading fountain of rock material that we call ejecta. Now, another thing that happened in this series of events is that a lot of energy was imparted to the Earth at the position of the Yucatan Peninsula. And the large amount of that energy was propagated through the Earth itself, and it affected rock material on the other side of the planet. Now, there's some very large volcanic eruptions called the Deccan Traps that occur in India. And one of the hypotheses that are being evaluated is whether or not that impact energy could have caused volcanic activity on the other side of the planet. An alternative hypothesis for the death of the dinosaurs that had been seen in the geological record from these fossil assemblages is that they were caused by large-scale volcanic eruptions. Now, finding the meteor impact crater was essential to understanding the story. And the way that Walter and Louis Alvarez went about doing this is that they found meteor impact deposits, which are very fine deposits of fine silt and mud that are actually fine-grained material that gets launched into the atmosphere, distributed around the planet, and then falls back to Earth slowly. It created this layer around the planet of this ash. And that ash, they found a very important element in it called iridium. And iridium is only concentrated in two places, either the core of the Earth or in outer space in these extraterrestrial bodies. It's very hard to get any material from the core of the Earth to the surface of the Earth, right? If that happened, it would have been a catastrophic event and the Earth would cease to exist. So you can cancel that out. And so the delivery of high concentrations of iridium require that you had an impact hit. And one of the primary sites where that impact deposit was identified was a beautiful little mountain village outside of, to the northeast of Rome called Gubbio. So they found a thin layer of fine-grained rock material that was enriched in iridium. And then they found this around the world using different geochemical and geological techniques. The next thing that happened was, well, they found the evidence of the ejecta going in the atmosphere and falling back, but where was the impact crater? Geologists had climbed around a planet for decades and hadn't found an impact crater of that right age. It turns out that during that time period, Mexican oil geologists were looking for oil and gas throughout Mexico, and they started taking geophysical measurements deep into the Earth. They'd put down sound waves, they'd collect changes in gravity that came back to the surface, and when they started putting these together, they saw something that looked like a crater, but it was deeply buried, 1 or 2 kilometers beneath the surface of the Earth. They saw a crater shape using these geophysical techniques, and they interpreted that to be it was a volcano. Well, then Walter and Louis Alvarez were on the hunt along with their colleagues for where this impact site might have been. Now, the Yucatan Peninsula, Mother Nature was very tricky by having the impact hit there, because not only was that the location of the impact and the crater and all these events at the surface, but then that particular location on Earth, it was subsiding. It was slowly sinking with geological time, and that continued to happen even after the impact took place. And in that position, as soon as the crater is formed and then the Earth starts subsiding, then it's near the ocean. And the ocean comes up and floods in that area, and then it lays down oceanic sediments. So you had kilometers of sediment that were laid over the top, and it hid the footprint of the meteor impact. And it wasn't until geologists looking for oil had identified a crater in the subsurface and then started to drill cores that they saw that this crater could not be a volcanic event because it was enriched in iridium. So the pieces of the puzzle started all coming together. And once that basic concept of a meteor impact killing dinosaurs at the 65.5 million year benchmark, which was the end and the demise of the dinosaurs, came about, then the entire story could be synthesized into one piece. So the KT impact is a great example. It took many decades to find and understand the processes that were surrounding one of the greatest geological events of Earth history. And at that time, the impact fundamentally changed the chemistry of the atmosphere. It blocked out photosynthesis, no longer having plant material for the dinosaurs to live off of. And some people hypothesize that the dinosaurs were already starting to decline slightly, and this might have been, if it wasn't the main reason, it was a complicating reason that caused the demise of the dinosaurs. So therefore, the KT impact event is a great example of how evolutionary biology is reset and fundamentally controlled in the long run by these ongoing frequent events of meteor impacts throughout geological history.